Hello, Year 12. Today we're going to have our first look at annuities, and then we're going to look at using annuity tables and finding future values from them. Okay, so what is an annuity? An annuity is, as you can see, an investment that receives interest in which regular payments are added to periodically. So you can think of this as like a savings account where there's an interest rate on that account, which will increase the amount in that account after each month, say, and you might budget so that you're putting a regular amount into that savings account every month. And so every month you've got money coming in, interest being added on, and that happens over and over and over. Okay, you could also think of superannuation, which after each paycheck, a certain percentage of your pay gets put into a superannuation account and interest is charged on that, usually at a higher rate than a savings account, which you can then access when you retire. So that is an example of annuity. Another example of annuity, which we'll be looking in a few lessons' time, is a single sum investment in which periodical equal withdrawals are made from. So instead of adding money into, you're taking money out of. An example of this is repaying a loan. So that is what an annuity is. Okay, now the future value of an annuity is just the value after the last payment. So after all the payments and all the interests are calculated, what is the total value of that annuity? The present value of an annuity is the single amount of money that if you invested that lump sum of money today with the same interest rate as the annuity, it would result in the same amount over the same period of time. Now we're going to look at that in the next lesson. Today we're just looking at future values. Okay, now the way that these annuities are calculated is using a sort of fancy formula. You can see it here. Future value equals A brackets, and you've got 1 plus n r to the n minus 1 over r. It's quite a complicated formula. Fortunately, we don't need to use this formula. We just need to know how to use the tables. But it's helpful to know sort of how these tables are generated, how those values are calculated. It's using that formula that you see there. Okay. Now we're going to look at our first question in a moment. So here is an example of an annuity future value table. So you can see here we've got interest rate per period in the rows, and then, sorry, in the columns, and then the number of periods in the rows. And we need to be able to find the right value that's in the right cell there based on the question. Okay, so we can just use the formula future value equals A times X. So A is the contribution made each time period. So let's say you're adding $100 each month, that would be your A. And then X would be the interest factor that you find from the table. So that depends on the number of periods as well as the period interest rate. Okay, so let's look at this question here. Use the table of values of future values. Use the table of future values to find the future value of an annuity of $800 invested at the end of each year for 15 years at an interest rate of 55% per annum. So first thing we noticed, our A value is 800. Okay, the number of periods is 15, and our interest rate is 55% per annum. And you notice that the interest rate per annum, which is per year, is the same as the number of periods we're given. So we've got 15 years and our interest rate is in years. We don't have to make any conversions. So we're going to use our formula, future value equals 800, because that's our value that we're making each time period. And then we've got to find, so it's 15 years in this row, and it's going to be 5.5 per annum. So we go down, and here is our value here. So it's in the 15 periods at 5.5% per annum. So our interest factor is going to be 22.4087. Okay, and then we just need to calculate that on our calculator to find our future value. So it's going to be 800 times 22.4087. 0.4087. Press equals. We've got our future value here. So after 15 years, making $800 every year, you're going to end up with $17,926.96. Okay, now for part B, we need to calculate the interest earned on the investment. So this is going to be the amount that we made, taking away the contribution we made each time times the number of periods. So if we had no interest, then it would just be 800 times 15, and that would be the amount of money that would be in our account. We're going to see how much more do we have than just that. So it's going to be the interest. It's going to be that value there, taking away, and we're going to take away $800 times 15, because that's what we would have if there was no interest applied. There was no interest factor as well. Okay, and then let's see what we get. So we can just take away from this answer 800 times 15. And you can see here there's quite a lot of interest earned on our annuity here. If we just put in 800 times 15, there was no interest, we would have been almost $6,000 worse off. So interest is a great thing. It's great to be putting money in early. So if you can raise your superannuation percentage, it's going to result in a much larger amount at the end of when you withdraw from your superannuation. Okay, let's look at another example here. We've got a slightly different table here, much smaller percentages, but we'll see in this moment why we would use this. Find the future value of an annuity if $200 is invested at the end of each month for 2 years at an interest rate of 3.6 per annum. So the main thing we need to notice is that we're adding it in each month, okay? And the interest rate is in per annum. So we first have to make sure we convert it from per annum, per year, into per month. So interest, before we do anything, interest rate, okay, is going to be 3.6 divided by 12, which equals 0.3 per month percent. Okay, and the number of months is going to be 2 times 12, which is 24. So it's 0.3% per month. And we've got 24 months, and our value of A is 200. So now we can use our formula, future value equals 200 times, we're going to find our interest factor. So it's going to be 0.3%. That's why we needed these smaller percentage rates, because we're dealing with per month. 0.3%, and we're looking at 24 months. So there's our value there, 24.8465. So let's put that in our calculator. 200 times 24.8465 equals 4969.30 dollars. So we found our future value here. That's all we need to do for this question. So again, make sure you're reading the question, make sure you're noticing whether the interest rate is given per annum and whether you need to convert it into a monthly interest rate. And make sure you're converting your number of periods from years to months if necessary before you continue with the question. Okay, boys, good luck. If you have any questions, you know where to reach me on Microsoft Teams, and I'll see you in the next video.